So back to your screen sharing.
Okay.
So, I clicked the wrong one.
Maybe.
Yeah. I should let you do it.
And this one.
Click it yourself.
Where is?
Or you want to?
Yeah, I wanted the.
Yeah.
But. Okay.
Here it is. I'll just change this. Minimize this. Okay. Okay, so it's my pleasure to introduce Filippo Costantini, Marie Curie postdoctoral fellow both at Campus Parry University in Venice and at McMaster University in Hamilton. Okay. Your title, Leibniz's Characterization of Quantity. Go ahead.
Well, okay, thanks very much for having me here today, and thanks for organizing this amazing conference, to Sidian and to Tom, Professor Vinci. So my talk will be about Leibniz and the way in which, in the 80s, in the 1680s, Leibniz characterized the notion of quantity. So it's a talk, let's say, in Leibniz's philosophy of mathematics, if you want. And why I focus on those years is because in those years, Leibniz had an approach to quantity via what we nowadays call definitions by abstractions, and essentially is a very close approach to what 2 centuries later Frege did in the Grundlagen and their arithmetic. So I think it's a very interesting approach. So just to give you a general overview of what I'm going to do today. So I will start by providing the logical context in which to understand this approach. Then I will briefly describe the abstractionist approach to the notion of quantity. So this is an approach that Leibniz applied to a number of different notions. Today, I'm just going to focus on the notion of quantity. Then I will raise a question that Leibniz didn't raise. And I'll try to find in Leibniz an answer to this question. So the third part is the more speculative part of the talk. So I'm happy to hear lots of criticism about this part. And finally, I will point out to a circularity problem that affects this way of introducing the notion of quantity, and essentially this circularity problem may give us a partial explanation of why in the 90s and later on Leibniz would opt for a different approach to the notion of quantity. Okay, so the logical context. So I guess everybody knows about what scholars have called the dream of the alphabet of human thought. So this young project developed by Leibniz. So the basic idea of this project was to provide an analysis of truth via an analysis of notions. So we want to analyze true propositions, we want to prove them, and the right way to do is to analyze the notions that compose these propositions. And basically, yeah, I'm very sketchy, but basically the idea is that we should decompose like the complex notion into the primitive components. Then we should recompose this primitive, once we have identified the primitive terms, we should recompose them by following some pre-established combinatorial rules. And all of these projects should happen within a formal language that Leibniz called the Characteristica Universalis. And one of the aim of this project was not only like to give rigorous proof of statements, but also to provide an ordering of truth. So we want to be able to show that some truth depends on others. So there is an order between different truth propositions. Now, this project has many problems, and Leibniz will stress some of them. So, for example, at a certain point, he points out that there may be infinitely many primitive notions. So it may be the case that we are not able to identify all the primitive notions. Another problem is that it is even not clear that when we find a primitive notion, we will be able to recognize it. But the key point for my aim today is the next one. So the idea that at a certain point, Leibniz realized that the ordering of truth already exists. And it already exists. So I guess that one example would be like Euclidean geometry, where like the theorems are in a way ordered. It already exists, even though, and that's the key point, we are not in possess of a full analysis of the basic mathematical concept. So here, one of the examples that Leibniz gives us is the example of arithmetics. So we know many arithmetical truths. We can prove that was true, but according to Leibniz, we don't fully grasp the basic arithmetical concept, which is the concept of prime number. And for a very specific reason, and the reason is that we don't have like an algorithmic procedure that tells us where to look for prime numbers in the scale of integers. So this fact suggests to Leibniz that we don't have a full analysis, we don't have a full grasp of these very basic arithmetical concepts. But even if we don't have this full analysis of these notions, we still have proof and demonstrations for arithmetical truth. So the idea that the analysis of truth via the analysis of notions, essentially this idea seems to be false. So we can have the former without the latter. And there is here a passage where this is said very explicitly. So Leibniz says, it's very difficult to achieve the analysis of things, so of notions, if you want, but it's not so difficult to achieve the analysis of truth needed. Since analysis of truth is achieved as soon as one has found a demonstration, and it's not always necessary to achieve the analysis of the subject or of the predicate to find the demonstration of a proposition. So here I think it's very clear that, I mean, the idea is that you can have an analysis of truth. Essentially, you can prove propositions without, so a proposition, or a sentence, as the forms, it's like we have a subject and a predicate. So we can prove that the predicate is in the subject without having a full analysis of the subject and the predicate. So really, the starting idea that the analysis of truth required the analysis of notion is here abandoned. So that was a bad idea. And the consequence, one of the consequences, is that the notion of proposition now becomes central. So here I've got a couple of texts. So the first one is from 1678, where Leibniz says, obliquities in complex terms. So here a complex term is a sentence, so something which has more components, while an incomplex term is like one component of a sentence. And obliquities are all the terms which are not in the nominative case. So it says obliquities in complex terms cannot be fully analyzed without the explication of some sentences. And here comes the important passage. Whoever thinks that everything concerning the complex terms can be explained before the complex terms are following a wrong method. In the same way as those who think that everything that regards the straight lines can be taught before the circles, or everything concerning the lines before the surfaces. So the idea is that if you want to analyze a term that appears within a sentence, and in a way you want to analyze the sentence starting from its components, well, you are following a wrong method. You must exactly take the opposite direction. So to understand the components of a sentence, you must start with a full sentence. And this idea will survive across the years, because we find in 1712, so a few years before Leibniz's death, a very similar claim. So Leibniz says, since abstracts are not entities, they must be reduced to truth. For example, the rationality of man is nothing else than the truth of this claim. Man is rational. From here, it is evident that the incomplex terms must often be grounded in the same complex terms, which, however, by their nature, are posterior to the same incomplex terms of which they are a connection. So again, the idea here, I mean, this passage is pretty interesting because it makes clear, I think, one important point, that this approach is very important when we have terms referring to abstract objects, like rationality. And it says, essentially, you should not take the term rationality and ask what is rationality. You should look at this term inside a true proposition, like man is rational. So the right way to understand rationality is to look at a proposition as man is rational. And so the idea is that, like, the incomplex terms, so the components of the sentences, are grounded. He said must often be grounded in the same complex term in the sentences. So essentially, what we have here is what nowadays people call the Frege context principle, and I think it should be called Leibniz context principle. So, like, a term referring to an abstract object should be understood in the context of a true sentence in which it appears. And essentially, this gives us, like, the logical background to fully understand definitions by abstractions. Because definitions by abstractions are definitions that introduce an abstract term by looking at essentially at a sentence in which the term is present. Now I'm gonna show you an example with the notion of quantity, how these definitions work. But the idea is that essentially the right direction of explanation should go from the full sentence to the components. Now, clearly, here you can, I think one can appreciate, like, the nominalistic aspect of Leibniz's proposal. So to reduce rationality to man is rational means to say that we don't have to postulate, like, an object which is rationality that exists out there. Okay? But essentially, rationality should be interpreted as a predicate of, in this case, human beings. Okay, so now I'd like to briefly give you essentially an example of how definitions by abstraction work in Leibniz. And here, I'm going to follow a paper called De Quantitate, so on quantity, which I guess, but this is only a guess, should be dated around the end of the 80s, probably. But this approach can be found also in other papers, in other writings from the 80s. So Leibniz starts with the notion of congruence. And this notion, we don't find really a definition in the sense that congruence is a kind of primitive notion. So what Leibniz says is essentially how we can recognize congruent objects. And this is how he characterizes congruence. So congruent are those things that, if they differ, they can be discerned only through an external object, or when they are in different places at the same time, or when an object C is made of gold, the other D of silver. And then he gives some very nice example. In this way, a pound of gold and a pound of lead are congruent. Today and yesterday are congruent. Any point is congruent to whatever other point, and an instant with whatever other instant. So the idea here is that if you have two congruent objects, I don't know, let's think of two triangles. To discern them, you must appeal to some extrinsic denomination. For example, you can discern congruent triangles by looking at their mutual position, the fact that I don't know, one is on the left of the other, or maybe by looking at their position with regard to a third object, as here is said. Because if you look at the proportions between the sides and the angles of the triangles, or if you look at the areas, you are not able to distinguish them, essentially because they have the same, exactly the same proportion, the same area. Okay. And I think that the notion of instant can help us here, essentially how you can distinguish two instants. Well, by looking at their location in time, which comes first and which comes later. And so essentially by looking at some extrinsic denomination. So extrinsic, as I guess everybody here knows, means that it's like an attribution that involves some reference to further objects. So for example, to a third object or like to the positions in space or time. So essentially this is like the idea of congruence. You may think of this idea also in the following terms. So if I've got two congruent triangles, I can in a way superimpose them. So I can take one, I can translate over the other, and at that point, I cannot distinguish them anymore. Okay, so essentially, there is no way to distinguish them anymore at that point. Okay, once he has the notion of congruence, he introduced the notion of equality. And in this way, so equals are those things that are congruent or can be made congruent through a transformation. Then he gives another definition. We can also define equals to those things that can be decomposed into different and disjoint parts, which are one by one congruent. But I'm going back to this definition at the end of this talk. So I will just focus on the first one. So essentially, it's saying if two triangles are congruent, then they are equal. So equality, you may think of equality as essentially a quantitative identity. So the fact that two triangles are equal means that they have the same area. But you can have like equals object even if they are not congruent. So I don't know, a square and a triangle with the same area would account as equal. And the idea is that you can take, I don't know, the triangle, you can transform it into a square with the same area and of the other square. And so you can conclude that the original triangle and the original square are equal. So essentially you need both the notion of congruence and the notion of transformation in this definition of equality. Okay, so congruence and equality, we can find this notion in this paper at the very beginning of the paper, when Leibniz is laying down his definitions. Okay, so he takes this as a definition for equality. And then a few pages later, he starts looking at consequences of those definitions. And he writes, from these definitions, we can derive the following sequences of axioms. Given the same measure, the equals are expressed by the same number, or they have the same quantity. Now, I won't say anything about measure now. I just want to focus on the second part, because in the second part, Leibniz is saying, if A and B are equals, then you can conclude that A and B have the same quantity. So he's introducing the notion of quantity via the notion of equality. Now, equality is an equivalence relation. So essentially what Leibniz is doing is to, so we can formalize this way in the following way, which is not how Leibniz clearly formalized it, but I think it's really just to write it down what it's doing. So we have on the right, we have the claim that A and B, which are two arbitrary objects, are equal. Okay, and this is said to be equivalent to the claim that the quantity of A is identical to the quantity of B. So it's really taking this equality as a quantitative identity. But the point is that it's not explaining equality by saying this is a quantitative identity, is doing the opposite, is introducing an identity between quantities via the notion of equality, which has been defined via congruence and the notion of transformation. So the point is, so this is essentially a definition by abstraction. It's not an explicit definition. It's not saying quantity is ... and then it is introducing some more basic notion. What is doing is to define what it means for A to have the same quantity as B. Okay. And to do that, so is essentially introducing a sentence where the notion of quantity appears. So it is an implicit definition, not an explicit one. And this sentence is introduced by means of another one, which says that A and B are equals. So in non-Leibnizian terms, we can say that it's like fixing the truth conditions of the sentence on the left, which is a sentence about quantities, by the sentence on the right. So the idea is that the sentence on the right should explain the sentence on the left, and by explaining this sentence, essentially we are able to introduce the notion of quantity. And notice that the notion of quantity essentially is an abstract notion. Why A and B are equals? This is a sentence about A and B. And A and B may be like lines, maybe whatever we can compare, okay? The sentence between the sentence on the left is about some specific aspect of A and B, namely their quantity. So the idea is, it seems that for A and B to be equals, it seems that there must be A and B. While for the quantity of A to be identical to the quantity of B, it seems that there must be something like quantities. Okay. So this is like an example of definitions by abstraction. Maybe the most important one is not this one, but is definition of the notion of situs, situation, where it defines not what situs is, but it defines what it means for like A and B to have the same situs. But I think that's a very interesting approach, because essentially it gives him an opportunity to introduce a notion which otherwise he wouldn't be able to properly define. And essentially it's really it's very close to what Frege will do 2 centuries later. And essentially discussions about this kind of definitions nowadays, I mean, there are lots of discussion about this. And I think that actually we can extrapolate from Leibniz a very original positions with regard to the contemporary discussion. Now, definitions by abstractions are also called abstraction principles. So when you write something like this nowadays is called, this is an abstraction principle. Because the idea is that if you go from right to left, you are in a way performing an abstraction. Okay. And so in the following, sometimes I will use the term definitions by abstraction or abstraction principles as seen. Okay, so this was like the example of definition by abstraction, the way in which quantity is introduced in those years. Now I'd like to raise a question that, as far as I know, Leibniz didn't raise. But this is one of the most discussed topics nowadays about abstraction principles, and it regards the relation between the 2 sides of an abstraction principle. So the definition in a way says that it is equivalent to say that A and B are equals, and to say that the quantity of A is identical to the quantity of B. And essentially the question I'm raising is, what does equivalence here mean? It cannot only be the fact that they have the same truth values, because the idea is that the sentence on the right, so the claim that A and B are equals, should in a way explain the sentence on the left. And just to point out that when one is true, also the other one is true is not enough. So this is not explicitly stated by Leibniz, but I think it's fully legitimate to ask this question as soon as one recognizes that essentially there is an equivalence between propositions which are different and which seems to have different ontological commitments. One is about A and B, the other one is about quantities, the quantity of A and the quantity of B. So essentially, for example, Frege used to say that in an abstraction principle, we are, so an abstraction principle is carving up the same content in different ways. So in Frege example, one of his example is if you say that two lines are parallel, okay, this is the same as saying that their directions is identical. They have the same direction. Parallel lines have the same direction. Okay. And Frege says, well, this is just, the two claims are equivalent and the two claims just carve up, so in a way describe the same content in different ways. And the problem is to understand which notion of content is suitable to have this idea. Okay, that different propositions are in a way equivalent. So here, as I was saying, this is like the most speculative part of the talk. So what I'm going to present is essentially a possible answer that I think we can find in Leibniz, okay, to this problem. So my suggestion is to look at Leibniz answer to Hobbes' idea that truth is conventional because it's based on definitions of words and definitions are conventional. So thanks to the talk given 2 days ago by Professor Normore, I realized that maybe Hobbes' position is a little bit more complicated of this, but for sure this is how Leibniz read Hobbes. And so it's interesting to see how it would reply to that kind of position. And here is the key passage from a dialogue written in 1677, where Leibniz says, for though the characters are arbitrary, so he recognized that the signs and words are arbitrary, their use and connection have something that is not arbitrary, namely a certain correspondence, proportion, between characters and things, and certain relations among different characters expressing the same things. And this correspondence or this relation is the ground of truth. And I will stop here because what comes after is not so important. So essentially, here it's appealing to a certain correspondence between characters and things, but also between different characters expressing the same thing. So clearly the point is what it means here with characters, what it means here with things. And so I will try to give like a proposal here. So first of all, I think that the correspondence is not at the level of words. If you look at the context, essentially the idea is that you can express the same things in different languages, so using different words. And so the correspondence should not be looked at the level of words. Characters maybe are arbitrary, and I think that this should be quite clear for most of the context. A bit more contentious is whether the syntactic structure of a sentence plays a role in this conception of correspondence. So let's consider a claim like Socrates is a man. So like some scholars here I've got in mind like Stephen Poole, I guess it is pronounced, I'm not sure, who like in his PhD dissertation talk of like the representational nature of language in Leibniz, and he gives this example. So I'm taking this example from him. He says, well, look, if you consider a sentence like Socrates is a man, well, this is true when the predicate being a man is contained in the subject, Socrates. And this corresponds to, in a way, that the semantic level where we have the complete concept of Socrates. So the concept that contains all the determinations of the substance Socrates. And essentially because like the concept being a man is a component of this complete concept. So there seems to be like a perfect match between like the syntax of the sentence and, if you want, the semantic level where we are dealing with concepts. Now, I think that the problem here is that we have a sentence about a substance for which there is a complete concept. But we are interested, at least I'm interested. So when we are asking about definitions by abstraction, we are interested in terms not referring to substances, but to abstract objects. And Leibniz is very, very clear that, so sometimes it distinguishes the two by saying a substance is something complete. We have a complete concept. An abstract object is something incomplete. There's nothing like a complete concept for an abstract notion. So in a way, there is a huge gap between the two. And so it's not clear that you can have like this, in a way, this idea that in a way the syntactic structure is mirrored at the level of the structural concept when we are dealing with abstract notion. And in fact, if the syntactic structure plays a role, we cannot, in this idea of this correspondence that would ground truth, well, this idea would be totally useless to account for a definition by abstraction, because we have no guarantees that the two sides of the definitions have the same syntactic structure. This is something also that is quite a lot discussed in the contemporary discussion of definitions by abstraction. So my point here would be, since we are interested, at least I'm interested in abstract notions, I cannot take that this view that syntactic structure with regard to sentences about abstract notions plays a role in this correspondence. And so in a way, my point would be the correspondence must be between the whole sentence, the whole propositions, and what Leibniz in that quotation called the things. So there must be some correspondence between like the proposition as whole and what the proposition is about. So if we put together the idea that the correspondence of which Leibniz is speaking is between the whole proposition, and this correspondence must ground the truth of the propositions, well, I think that a very natural idea here would just be to say that essentially the two sides of a definition by abstraction, so the claim that, for example, A and B are equals, and the claim that the quantities of A is identical to the quantity of B, are equivalent in the sense that they are made true by the same state of affair. Okay, so this is essentially the proposal. They have the same truth maker. They are true in virtue of the same portion of reality, of the same fact. Okay, and so I just go back 1 second to the text. Sorry, here. So I would interpret the characters and things. So characters is in the plural, so as like denoting a full sentence. Okay, so there's a correspondence between sentences and things, and the second claim, certain relations among different characters expressing the same things, essentially is the idea that we can have different sentences. Okay, which are different, but which express the same things. And so the idea is they express the same things in the sense that they are made true by the same state of affair. Now, a state of affair essentially is something complex. It's like, I don't know, an object with a property, more objects in certain relations. And the idea is that state of affairs are what makes true propositions. Now, you may worry that, well, this is not really a Leibniz notion. So it's not that I'm projecting into Leibniz some like contemporary idea. Well, I would argue this is not the case. So here is a passage where Leibniz used the word state in a way that really is like we nowadays use the word state of affair. It says, let us call L the state by virtue of which A is B, and then the state by virtue of which C is D. So it is essentially introducing a term to denote something complex that we can describe as A is B. this is essentially a state of affairs. So the state of the fact that A is B. Okay. And if you look at the Generalis Inquisitiones, which is Leibniz's most developed work in logic, and he has this notion of logical abstract. Logical abstract are things like being rational, being mortal, as opposed to rationality and mortality, which are called by Leibniz philosophical abstract. Now, I don't need, it's not really necessary to go inside this idea about logical abstract, but the idea in the Generalis Inquisitiones is that we can use logical abstract to take a sentence and transform it into a term. So like a sentence like A is B is translated into something like A being B, or the A-ness of B. And this is done because he wants to show that every kind of sentences can be reduced to identity statement, or the form something is identical to something else. Okay. So proof is like to reduce truth to identities. And in this way, for example, if you have like a claim like if A is B, then C is D, it will become that the A being B contains the C is D. So you have like a conditional statement reduced to a categoric statement. But the point is that essentially A being B is just a term for essentially something complex, a state of affairs. And this actually allows us to, in a way, translate Leibniz's theory of truth. So the idea that a proposition is true when the predicate is contained in the subject by means of like the notion of state of affairs, because the containment, so truth requires a relation between a subject and a predicate, and that relation is, you can call it a state of affairs. Okay. A is B is true in virtue of the fact that like the predicate B is contained in it. So I think that it is quite innocuous to use this notion of state of affairs in this context. And we can also have like hints from Leibniz that it wouldn't matter to use this notion. Okay. And so the idea is that how to account for the equivalence between the two sides of a definition by abstraction? Well, by saying that they are made true by the same state of affairs, by the same portion of reality, if you want. So the equivalence is, I would account the equivalence as they have the same truth maker. But clearly, there is also a difference between the two claims, the claims that A and B are equals, and the claims that the quantity of A is identical to the quantity of B. And here I think that the point is that Leibniz sees an asymmetry between the two claims. So they are equivalent, but there is also an asymmetry in the sense that it is the claim that A is B that explains the other. It is the claim where we have like an abstract terms that should be explained by means of the claim without the abstract terms. So clearly the asymmetry is linked to Leibniz's nominalistic view. So the idea would be the two claims describe the same state of affairs. They are both true, but in a way there is one description which is more faithful. So the descriptions are not all on a par. Okay. There is this asymmetry because ultimately we must, in a way, our ontological commitments, we should not take like ontological commitments from the claim with abstract terms. We don't need to think that there are abstract terms, abstract objects to like quantities, to think that the quantity of A is identical to the quantity of B. It's just enough that there are A and B and that they are equals. So I think a nice way to put this, maybe a bit metaphorically, is say that an abstraction principle or definition by abstraction expresses different perspectives on the same portion of reality. So yeah, I was playing a bit with the notion of expression in the sense that it reminds me of like a bit of this late theory of monadic expressions, where essentially each monad expresses the same thing, so the universe, but from different perspectives. So maybe we can say something similar here we have like two planes that express it the same from different perspectives. But probably this analogy would be that in the case of definition by abstractions, there is this asymmetry. While I don't think that there is this asymmetry between these finite models. Okay, so that essentially is my proposal to make sense of the equivalence between the two sides of a definition by abstraction. I hope it's clear. So the last part, I'd like to point out to a visual circularity in this way of like presenting those concepts. So if you recall, equality has been introduced via the notion of congruence and the notion of transformation. The point is that the notion of transformation is a technical term in Leibniz. So a transformation must always preserve equality. So if I transform an object A into an object B, they must be equal. Otherwise, I wouldn't have a transformation. And this is, for example, expressed in this quotation where it says that, well, magnitudes or quantities is what managed, is what is preserved in a transformation. Okay, so it's very tempting to say that we need the notion of equality to define transformation, but if this is the case, we have an evident circularity. So, because we are defining equality via transformation, and then transformation would be defined via equality. So, a proposal to avoid this circularity would be to look back at the second definition of equality that he gave. And maybe he gave the second definition exactly to avoid to use the notion of transformation in defining equality. I don't know that, but that's a possibility. So I just go back to the second definition. That is very back. It's here, where he said we can also define equals, those things that can be decomposed into different and disjoint parts, which are one by one congruent. So the idea is that if you have two objects, you want to show that they are equals. The idea is you decompose them, so like two triangles. Mainly Leibniz has in mind example from geometry. Okay. So you have two triangles, or I don't know, a triangle and a square. You decompose them into parts. These parts must be disjoint, which means they have nothing in common. They don't overlap. And if the parts are one by one congruent, you can conclude that the two objects are equals. Another way of thinking of this is to say I take an object, I decompose it into parts, okay, like a triangle. I rearrange these parts. I form like a square. And I can conclude that the triangle and the square are equals because they are made up of the same parts. This is roughly speaking the idea. And clearly you can take these parts as small as you want. So in a text, it speaks of minima, indicating the fact that you can take the parts as small as you want. So the idea is that for a certain part, there is always a smaller part. Okay. And this allows you to like approximate things as precise as you want. So one may think, well, these definitions allows us to avoid the circularity because we are defining equals, not via the notion of part and the notion of congruence, but not via the notion of transformation. And the problem was that transformation required equality. Okay, but this does not work for one simple reason, that the notion, if you look at the definition of part, well, I'm just going on, but I don't have any more slides. Sorry. If you look at the definition of parts, so parts is not a primitive notion in that case. It's defined via the relation of containment, being in, and the notion of homogeneity. So A is a part of B if A is contained in B and is homogeneous to B. Now, if you look at the definition of homogeneity, well, it requires equality and the notion of transformation. So it's to define equality via these decompositions into parts doesn't resolve, I mean, the problem of this vicious circularity, because then you will find again the notion of transformation and equality in the definition of homogeneity. Now, it seems to me that when he has this approach starting with congruence, these kind of circularities are present. And I think he was able at the end to find a presentation of this theory of quantity, which is free from these vicious problems. But essentially, I've got in mind the presentation that we find in a paper called Inizia Rerum Mathematicarum Metaphysica, which is from 1714. So it's a late paper. But in that paper, essentially, quantity is not introduced anymore via definition by abstractions, but it is introduced straight away in a similar way as here he introduced the notion of congruence. Yeah, and essentially this was everything. So thanks for your attention. Let me stop sharing.
Thank you very much. I'll leave the floor to Leibnizian specialists, people knowing Leibniz for more than that. Or I will start the ball with a question, because when you find a congruence, you had talked to me 2 days before about homogeneity, which you brought up only at the end. And I looked at your definition of congruence in Leibniz, and I thought, oh, then what's the difference with homogeneity? So perhaps I can re-ask that question to you now that you've talked about homogeneity at the end, but those terms are quite big.
Yeah, so the difference between, between homogeneity and congruence. So, for example, a part of a whole, so like if you take a line and you take a segment in the line, okay, the segment is a part of the line. So it is homogeneous to the line in the sense that they have the same dimension, they are both one-dimensional objects. But the segment is not congruent to the line. If we suppose that we are taking like a smaller segment. To be congruent to the line, essentially we need another line with the same length. So congruence means, so if A and B are congruent, you can prove that they are equals. Essentially they have the same length, and they are also similar. Now you're right in pointing out similar means that essentially from a qualitative point of view, from the intrinsic properties, they are the same, they have the same qualities. Now you're right in pointing out that these notions are linked, because also if A and B are similar, well, they don't have to be equals, so they don't need to be congruent. Two lines with different length are similar, but they are not congruent and neither equals, so, but they are homogeneous. So
okay,
they
is it possible that homogeneity has to do with qualitative aspects of the two things compared, whereas congruence would have more to do with quantity, as you suggested?
Oh yeah, I mean, in congruence there is like a quantitative aspect. So essentially at a certain point, so in this paper, in a way, it proves that if A and B are congruent, then they are similar and equals. So there is this equality aspect. In other presentations, it defines congruence as with equality and similarity. And yeah, homogeneity, yeah, regards also, so it has this qualitative aspect, homogeneity. So this is like, I think, a difficult concept, because it sometimes he uses it also outside the mathematical realm, and it says something like, it seems to think that if two things are of the same kind, they are homogeneous. But for sure, if A and B are similar, which means they are qualitative identical, they are homogeneous. So homogeneity has to do with quality. I would add that essentially the idea is that you can have homogeneity only between objects of the same dimensions. So a one-dimensional object can be homogeneous only to another one-dimensional object. So a point is not homogeneous to a line is not homogeneous to a plane is not homogeneous to a solid, a three-dimensional object. And so, for example, a point is not a part of the line, but it is in the line. It is contained, it is a requisite of the line. Yeah, if you want, I can say also more. So from a mathematical point of view, homogeneity, the term was used to characterize like Archimedean quantities. And the idea is that Archimedean quantities or magnitudes are quantities or magnitudes that can be compared from a quantitative perspective. Yeah, I don't know who was first.
I think there's also that.
Oh yeah, follow up.
Yeah, so for the homogeneity, just like can we imagine like two sets, and like the two sets contain like the same like numerical elements, but the elements in the set A is like homogeneous with other elements in the set A, but the elements in the set A is like congruent with the elements with set B. Can I understand it that way?
Well, I'm not sure I got it. I understood what you mean. Well, I mean, first of all, talk of sets is a bit, it's very anachronistic with regard to Leibniz. But, so can you rephrase what you mean? Because, so I mean, we can talk of collections, I guess, that would be.
Yeah, so I'm thinking of like if all the elements in the same set, like the set A is like of the same quality, but they are not really contained in the another set. Though that imagine that the set A contains number 1, 2, 3, 4.
Yeah.
And the set B contains another like 1, 2, 3, 4, but the first set A only so it's like 1A, 2A, 3A, 4A. And the other set, the elements are 1B, 2B, 3B, 4B. And 1A is like congruent with 1B, but 1A is homogeneous with 2A. Can I understand that?
Okay. Yeah, I think I guess I understood what you mean. So, yeah, I mean, here we are speaking of parts, not of like sets. So parts and whole and not sets. So the idea with sets is that you can put together, you can have a set with whatever elements you want. So they can be like, yeah, numbers, but also you can have a set with a number and a concrete object. So they don't have to share any qualities, indeed. But I guess you are thinking of the example when we decompose an object into parts, and we decompose two objects, and then we confront the parts and we say that they are congruent. Well, but that procedure essentially presupposes that when we start with like triangles, for example. So objects which have the same dimensions, and so they are homogeneous because they can be compared. And we decompose them into parts. The parts are homogeneous to the original triangles. So the parts of triangles A will be homogeneous also to the parts of triangle B. And then we can compare them. And the idea is that if we can pair each part of A with a part of B, and in such a way that they are congruent, so essentially this guarantees that the parts, we have the same extensions if we are talking about two-dimensional objects. Then you can conclude that also the original objects have the same extension. That was the idea. But yeah, Leibniz didn't think in terms of like sets. So for example, if you consider the integers, okay, so he has an argument to say that there is no infinite number. There is no number of the integers that tell us how many integers there are, because if it were, we would have a violation of the idea that the whole. So we would treat the integers as a whole with parts, and we can find a violation of the idea that the whole is always bigger than the parts. So yeah, I mean, yeah, it's a bit different with like the set terminology. Yeah, I think there was either what I saw before Nabil and then Roberto and then I guess me.
All right, so I'm interested in the part of your account that is supposed to Leibniz's response to Hobbes' conventionalism.
So
to Hobbes' conventionalism.
Oh yeah.
So the thing that the part of your account of that is that the Leibniz's account by abstraction with two sides of the definition are they have the same truth basis.
Yeah.
I was wondering if there's something more to it than that would part of the account in order to be a satisfactory response to.
Sorry, can you?
More about the definition, like tell something about the nature of truth makers, or I don't know. Could you say more?
Yeah. Okay. So the first point would be that. So definitions by abstraction, we can have those kind of definitions only for abstract notions. You don't have like definition by abstraction for like substances. Okay. So like the state of affairs that would make true a proposition would be something concerning, like, for example, relation between concepts, or yeah, in the case of the notion of quantity, the fact that, I don't know, two lines are equals. Now, the point, I think, to ask for something more than just to have the same truth maker, that may be dangerous, because, I mean, the problem is that essentially you need a notion of content. I mean, in order for a definition by abstraction to work, you need a notion of content that is fine-grained enough to allow you that the two sentences are different. But it must be coarse-grained enough to allow you to say that they are equivalent. And if you go like for a view like, well, there is a notion of propositions, it's called like structure propositions, where essentially you individuate, I mean, a proposition is individuated also by looking at the syntactic structure. So the syntactic structure plays a role in this notion of structure propositions. So essentially, if you have a proposition with different syntactic structure, that is enough to say that they are not equivalent. Well, this notion cannot be used to account for the equivalence in an abstraction principle. So you cannot have at the same time definition by abstractions and a notion of proposition like structural propositions. And so that was the reason why I spent time to say, we have good reason to think that when we have like sentences about substances, also the structure of the sentence plays a role, but not when we are dealing with abstract terms. So it may be that actually we can say more than just say they have the same truth maker. Now I don't know exactly, I wouldn't know what to say, but one must be very careful, because I mean you need a notion which is not too fine-grained, not too coarse.
I guess what I'm wondering is that this is still compatible with the state of affairs that are expressed on the side of
yeah.
Being linguistic states of affairs.
Oh yeah, you may say that, yeah. Yeah, you may say things like that. So essentially, you have two sentences, two different linguistic sentences expressing the same state of affair, right? Is what you are meaning? You're saying?
The meanings, what the state of affairs itself, obviously, can be cashed out in terms of convention around.
Yeah, you may say there are two different state of affairs. Yeah, I mean, yeah, you could say that, but I mean, if you say that, at that point, you cannot say anymore that it's the same state of affair that makes true the two statements. If I got you wrong, right. There was another point that I wanted to say. Oh, okay, I just forgot. Yeah, I think. Yeah, but okay. So I guess Roberto.
Yeah, thank you. I am afraid my question won't go into the details of your of the demonstration, but it's more related to the premises of your talk and the methodology that employed by Leibniz. I was struck by the initial claim according to which demonstrating the truth of a proposition is easier than demonstrating the truth of the names, or like that it is easier to demonstrate like the coherency of a complex object rather than that of a simple object. And then if I remember correctly, Leibniz lays down a geometric example, like that it is easier to understand the properties of a circle before we understood all the properties of the lines and so on. So my question was just purely contextual. I mean, whether Leibniz had any take about what was, I think, by the day the standard geometric Euclidean Clavius-inspired methodology that starts from simple concepts, rules of behavior like axioms, and then derives the propositions, namely the theorems, and proceeds in that way. And as a corollary, whether Leibniz had any account of something like a self-evident truth on which to rely upon. Thank you.
Oh yeah, thanks very much. Yeah, I mean, you essentially you really like Euclidean geometry, and it's not the case that it's not the case that you don't have to start with like definitions of like concept and then try to prove propositions. The point is that we don't need a full account, for example, of a full definition of what a point is, for example, or what, I don't know, a line is. We can just work with like, or for example, in the case of mathematics, clearly we have some grasp of the notion of prime numbers. The point is that we don't need a full grasp. So there may be aspects of those notions that are not available to us, and still we can prove things. So so when you realize that it's not really in our possibility to determine all the primitive notions, another proposal, because essentially he makes like a bunch of different proposals, is to say, well, look, but we can take like in a single field, we can take some notions and treat them as if they were primitives. So I guess he would say something similar to like the axiom of Euclid, and we can work starting from them. So just suppose that they are primitive, and then we work from them. But it may be that actually there are points that we don't fully understand about these notions. So so it's not the case that I mean actually, when you look at how he proceeds, so he even introduced, so for example, in the quantitate, he starts with like the notion of congruence, he defines equalities. So he has like his own primitive notions there. And he tried to build all his topic starting from those notions. And another point in this regard would be that essentially the idea, one key idea here is that, okay, your question was about self-evident truth. Yeah, essentially it would consider axioms as, at least some axioms as self-evident truth. For example, I guess it would consider like a claim like the whole is always bigger than its part as a self-evident truth, but still it tried to prove it, because at the time, essentially everybody wanted to prove axioms. And the proof was from definitions. Essentially, the definition he gives is that A is less than B, is smaller than B if A is equal to a proper part of B. So a part of B not identical to B. And then if you suppose that you have an object and a part of this object, then you have that the part is equal to itself. So the part is equal to a proper part of the whole, and so the part is smaller than the whole. So this is, roughly speaking, is demonstration of. But yeah, I guess I would consider like that example as a self-evident truth. And essentially, yeah, also all kind of identities would be like, and with identities, so one of the things that comes out from the idea that we may not grasp the full concept, the full primitive concept, is that a demonstration is a reduction of a proposition to an identity. But an identity is not only a proposition of the form A is identical to A, but also like proposition as A is equal to B, or A is similar to B. So where you have equivalence relations, there are considered identities. So for example, the definition by abstractions, you may think as I've got the claims, the quantity of A is identical to the quantity of B, and I'm reducing it to the identity A is equal to B. And that's a sort of identity because the idea is that A and B, since they are equals, they can be substitute one from the other, salva quantitate, so preserving quantity. So when you have this substitution, essentially there, it means that there is an identity there. Yeah, I hope to have said enough. Yeah, I guess. Well, but thanks for the question. So I guess there is Professor Normore.
Yeah, I think there's a certain irony in the thought that the most self-evident truth turns out to be one that's actually abandoned in contemporary mathematics. Yeah. But my question is really about the thought that that there is a circularity here, and I may have misheard you at this point because there was a kind of echo. But if we go back to the definition of transformation, it looks like it doesn't involve any abstract terms, right? It involves only the notion of similia, not the notion of similarity. And I'm wondering if Leibniz might be thinking something like this: that we can identify the similars without, so to speak, having the abstract notion of similarity. And once we have the notion of similars, we can identify the transformations. And once we have the transformations, we can identify equality and the other abstract terms that are involved. And if that were right, then there wouldn't be exactly a circularity. There'd be a reliance on this more primitive notion of the similia. And that would be a very nominalist thing to do, right? It's, for example, Occam has to make exactly the same move in just giving you the account of what, say, a human being is. A human being, right? Humans are things that are similar in certain ways. More exactly what he says are essentially similar. And so somebody might respond to him by saying, well, look, don't you need the notion of similarity already then? And he would just say, no, I cash out similar just by looking, Peter is similar to Paul is just Peter is and Paul is, and there's nothing more required as its truth condition. So I'm wondering if you could say something like that a magnitude is that which remains in a transformation in which only similars are discerned, and you don't need anything more, just those very things that you are looking at. And would that solve the problem?
Oh, yeah.
Problem. In fact, did I miss you?
No. Well, thanks very much. So first of all, I would say that this definition is actually a definition of characterization of magnitude or quantity, and not really of transformation. So it says that. So here my point was simply that a transformation should preserve magnitude equality, because so what it's saying is that essentially magnitude is what is preserved in a transformation, or magnitude is what can be discerned essentially just by looking at similar things. But I think that you got the point right, in the sense that, so I think there are two approaches in Leibniz, at least. So when he has this abstractionist approach, so in the Quantitate, he introduced similarity by saying, directly by saying that you can recognize similar things, essentially by distinguishing them by their quantity. So you must, in a way, you compare them, and if the only way to distinguish them is essentially that they have different quantities, so from their qualities, you cannot distinguish them, then they are similar. So the idea is that he has the notion of similarity, and then he can introduce, if A and B are similar, he can introduce the fact that A and B share the same qualities. But later on, so for example, in the paper I was quoting before, the Initial Rerum Mathematicarum, he goes for the other way around. So he starts with quality, the notion of quality and the notion of quantity. So he says quality is what you can grasp in an object when you can consider the object alone, singly. You don't need any comparison. And what you grasp is the qualities. Okay. If you need to compare, so when you need to compare objects, well, you need to compare objects to grasp the notion of quantity. And once he has the notion of quality and quantity, he can define similar as things that share the same qualities, and equals as things that share the same quantities, the same quantitative aspect. So if I get you right, you were saying that this kind of approach would be free of any circularity, I guess, and I agree with that. I think that what he did in the Initial Rerum Mathematicarum is he did a very good job there. I think I really like that paper, but here is doing exactly is taking the other direction. It's really essentially, if you compare the two approaches, you will find that the same propositions are true, but the direction of the explication is reversed.
Thank you. Thank you. Can I just add, in response to Alberto, remark in your comments, that when he turns to the elements of the calculus, Leibniz seems to rely on the notion of relative primes. Things that are, so, I mean, the fundamental idea is that you analyze everything into concepts which are to each other as prime numbers and blah, blah, blah. But you don't need that to determine the truths of propositions. You only need that whether or not the subject and the predicate are prime relative to one another. And so you don't need a full analysis of either the subject or the predicate in order to do that. In his characterization, he seems to have this idea very clearly, very basically in his picture. You know, thank you very much, by the way. That was a great paper.
Thanks a lot. Nicholas?
Yeah.
Oh yeah, I stopped sharing. Okay.
Paul, thanks for the talk. Really interesting. And so my question is sort of concerning the utility of the abstraction principle. I'm just wondering some of your thoughts on this. So
Can you speak up a bit? Because
yeah,
I don't think they
so
can really hear you from.
I'm just I'm curious about what you think some of the utilities of the abstraction principle. At one point, you said that something like abstractions are not entities, and they're only sort of terms referring to abstract objects. But there's sort of I can kind of see some application here because there are so many abstract things in Leibniz's system, sort of in his metaphysics. So, for example, like I'm wondering if we can sort of use the abstraction principle to look at something like, okay, like, well, matter is, you know, in a sense, it's ideal, and therefore abstract, and body as well, I think. So I'm just wondering if we could sort of use this abstraction principle to then sort of, you know, do whatever logical operations we can with these terms, and then, you know, determine how they can be sort of what we get out of that and what relation they have to other sort of things in his system, just because there are so many abstract things going on for this. So anyway, I'm curious as to.
Okay. So first of all, the utility. So for example, so the utility in the mathematical setting, I think it's very useful. For example, the notion of situation or place is defined via definition by abstractions. And I think because Leibniz realized that he was not able to give a direct definition. Situation is a kind of primitive terms. And in the letter, in the correspondence with Clark, he says, well, look, in the case of situation, what I define is what it means for like A and B to have the same situations. And he says, I'm following Euclid here when Euclid defines what it means for magnitudes to have the same ratio. So I think that in the mathematical setting, they are very useful because it allows you to introduce a concept even if you are not in the condition of giving an explicit definition. Moreover, it gives you a way of introducing a concept by making explicit the conditional identity for that concept. So you're not speaking in a quite vague way, you have a concept with this conditional identity. Okay. Now, if we want to look outside mathematics, well, for the notion of like matter, bodies, well, I think it would be quite difficult. You should be able to define equivalence relations of some kinds to have definition by abstractions. For sure, you can have like this approach with the notion of like, I guess with the notion of possible words, you can have something. I'm actually thinking of some work of Richard Arthur, but now I guess when you have the notion of composibility, there should be an equivalent relations. And so you can exploit there some kind of definition by abstractions. But I should like look at the text now because, but yeah, with the notion of matter, I can just tell you like a first impression. I think it would be quite difficult. But maybe it's not impossible. So it's something like to look at. Yeah. Yeah, I'm sorry, I cannot really now say something more at this point. Yeah.
Okay, well, everyone is in agreement. We may stop this session, and thank you again, Filippo, for this very
well, thanks for the discussion.
thought-stimulating paper. Thank you. And so yes.
Yeah, I
we
stopped the recording.
And,